Okay, so two special cases of exponential growth and decay. Both on or off?
No, just one off.
Just one. Okay. So, the two special cases are half-life and doubling period. Half-life comes up a lot when talking about for chemistry and science, because every chemical has a natural half-life decay rate.
Isotope?
Isotope, yes.
Oh, that's right. I just did
Chemistry, I know. Every chemical in the periodic table has its own half-life, which is the amount of time it takes the substance to decay naturally to half of its size. This is how carbon dating is done. You know, they when they find fossils, they want to know how old the fossil is. We know what the half-life of carbon is, so we can figure out how much carbon is left over in the fossils. We can then work our way backwards to see, well, how long it would have taken to get to that size. And then ultimately can then say, okay, well then it took this million years. This is how old this fossil is, a million years old or whatever. It's a decay rate. So again, think about this. Everything on the planet, in the universe, I believe, has a decay rate. Right? That's why when they talk about, say, when you have nuclear waste, or even just regular waste. So the big thing about landfills and the waste that we produce is particularly things like plastic that we throw away will sit in the ground and will take millions of years for that plastic to decay into something that's actually can be used. So that's why people are always so big about not wanting to put plastic in landfills, because it takes forever for that to be actually decay. Because it's plastic, which is part of carbon, has a long decay rate. This is the formula, or equation I should say, that we use to calculate the decay rate, our half-life. F of x, again, represents the amount of the chemical isotope that we're talking about, that we have left. K represents the initial starting point, just like in the last formula. Because we're talking about the half-life, our decay rate is a half, or 0.5, yes?
Our page has like AL, AO instead of F of X.
Oh, I hate that notation. Okay. You have A with the little lower stick O.
Yeah.
That just represents the initial amount. And then A, the other one would be what's left over.
Can we just use those? Oh, can we
Yes,
just use those?
you can use these.
Okay, sure.
It's just notation. It's the same. Represents the same thing. The X represents the time period that we are calculating, and then the H represents what the half-life period is. Notice this is a fraction in the exponent. X and H must be the same time period. So if you're told the half-life is in years, you should be calculating X in years. If your half-life is in hours, your X should be hours. They need to be the same period. So if you're told that your half-life is in years, but you want to know, well, how much will I have left after 2 days? You need to convert days to years. Okay? They must be the same unit. Sometimes if you guys don't read your questions carefully, you don't notice that they're not the same unit and you don't get the right answer. So please pay attention to your X and your H. They must be the same time period. Let's do an example. So as again, this is just the typical thing of, so if you had 64 milligrams of a substance and whose half-life was every, oh, there's not given a half-life here. So you're saying after one half-life, it's decreasing by a half every time. So after one half-life, it's 32 milligrams will be left. After two half-lives, we're down to 16. After 3, we're down to 8, and so on. It's the amount of time it takes for a substance to become half of its size. And again, just like what Ryan said earlier, technically, you never actually officially ever get to 0. In theory, in the math, you never actually get to a fully 0. You always have like minute traces of the chemical. But there does come, when it comes to talking about reality and dealing with certain things, there does come a certain point where even the traces are so, you don't have the technology to detect traces that are so tiny, so we just say there's nothing there. It just gets smaller and smaller and smaller. This is how, not to sound morbid, but this is how we decay. When we die and we're put in the ground, we decay.
Wait, how long does it take?
For a person, well, for the, I can't remember the exact time period, and plus when we're put into coffins, the coffin tends to give us a little,
Okay, but let's say you're just buried in the ground.
you were just buried in the ground.
And does it like take like a month?
It takes a while. Oh yeah, it would take probably within a month your like soft tissue decay, but that's mostly not because of natural decay rates. That's because insects and stuff come and feed on you.
Like if it rains a lot, does your body decay faster?
We do math.
I was
Can
watching
we
this
not
thing
do
where
this?
this woman killed her baby and then
Oh, okay, Natalie,
That's
we're
why.
not gonna go into that. But in terms of like the bones,
Alright.
the bones will take many years to
Decompose, yeah.
decompose. That's why you can see people, they still dig up, they'll still find, when they're building some building, they'll find bones of people that are 1,000 years old. It takes a long time for bones. That's why, again, with the fossil records, when it comes to dinosaurs and stuff, like thousands, 10,000, 100,000 years, you could still have bones and fossils that are still
Their bones
contained.
are bigger.
Yeah, so it takes longer to decay.
Isn't it like not actually bones? Like,
It's sometimes the fossil is just like an indentation of where the bone used to be, but sometimes you can still find, depending on how and where the animal died. Like there's a lot of things where people are finding like actual still tissue because they were frozen. Like they found recently, they recently found a frozen person up in Everest.
Sounds like
That was like
something
over
bad.
100 years old, and definitely with freezing, things last much longer
But, like, was
when
it
it's frozen.
Bones?
No, like fully formed person.
I heard it
because
was
it was
like-
frozen.
I heard it was like a
That's
little
wild.
like Aboriginal girl or something.
Yeah.
That's actually terrifying.
Again, we're getting off a little slightly off.
Imagine just
If I
climbing
was
up that thing to find a dead goat.
Anyway, moving on. Let's do an example.
So you're recording?
Yes.
That's great.
Let's do an example. We've got a certain radioactive material has a half-life of 35 days. Just so you know, all of these half-lives in these questions are made up. Most things' half-lives are millions of years. So when we say a half-life, there's very few things that are like days of a half-life, except certain man-made things. That usually certain man-made isotopes and stuff can have short ones. Yeah.
Ours says 350 years, and how many will be present in it?
Oh,
Yeah.
is it?
Yeah.
I'm sorry. We'll just go with it. 350 years?
So should we just change it to 1
No, I will change it. What is? I'll change it. Don't worry. And how many? What's your time period?
35 days.
35 years.
35 years.
Years? It says days.
Years.
Oh, I read up there.
Okay, you have 100 grams of what? And the half-life is
Half-life is 35
35 years.
35 years.
Yeah.
And you want what for X?
Grams will be present in 350.
Oh, in 350 years. Okay. Okay, so we'll change this and that. So let's calculate this. H and X are the same year, so we don't need to worry about that. So that means our f of x is going to be 100 times a half to the power of 350 over 35, which is just 10. So really what we're calculating is 100 times a half to the power of 10. And then you can plug it in. With the calculator, we'll see what that gives you.
Okay, so after 500 years.
What?
The frozen
Search
girl.
up the thing.
What's 500?
Oh my
you,
God.
you looked it up?
0.0976.
So what is this? 100 times 0.5 to the power of 10 gives us 0.00976 grams. So we're left with that after 350 years. Yeah.
Just got 0.097625.
Yeah, that's what I got.
No, you put 2 zeros in front of the 9.
100 times 0.2. Oh, I put 2 zeros, but then I only put 1 zero there. I don't know what I'm doing.
It's alpha.
whatever your initial amount is.
Is there an example of different like things?
It should be the next one. Let's hope the next one is right. Let's make these corrections. This formula isn't that difficult. Oh, again, don't forget you should do your less statements. People tend to forget less statements. So make sure you're saying x represents the time, f of x is going to represent the decay amount. Let's do this one. Is this right?
I don't know.
We've got, so iodine 131, used to determine whether it's thyroid deficiency. That doesn't matter. So the half-life of iodine is 8.2 days. After how long would 25% of iodine be remaining? So I let x represent, x represent the elapsed time. F of x is going to represent the amount of iodine left. Now we don't know the initial amount, but we don't need to know the initial amount here because we're talking in percentages. Yes, Julian? Sure. Okay, so in this particular question, we don't have to have the initial amount because all I want to know is the percentages left, 25%. So we can let f of x be 25% of my initial amount, k.
Wait, can you just explain again? Oh, never mind, I got it.
You sure?
Yeah.
If k is our initial amount,
Yeah, I know.
we want 25% of that. So ultimately the k cancels out. What we're looking for here is x. We don't know how long this will take. So here we're looking for the exponent. So the fact is, just like we did before, you're going to need to figure out the exponent that's closest to 25%. Well, this one's actually easy because 25% is 1 over 4, which is a half squared. This one you don't even have to estimate. This is an exact. Now there was the face.
What you do?
Well, 0.25. What's 0.25 as a fraction?
1 over 4.
1 over 4, right?
Sorry.
0.25 is 1 over 4, and 1 over 4 is a half square,
Oh, yes, you're right.
right? 1 over 4 is a half square. So I can get a common base of a half. So that means that 2 is equal to the x over 8.2. To solve for x, we can cross multiply. We get that x is 16.4. Anytime a question deals in percentages, how long will it take to be 30% of the size? Or how long will it take, or like that question we talked about with the disinfectant, how long will it take to have none? You just look in terms of the percentages, and the k value, you don't need the initial amount. You just treat k as k and then it divides out. Natalie, you still look confused.
Yeah.
Where did I lose you?
2.
Which 2? This 2?
Yeah.
Remember, once we have the base the same,
Okay.
we can set the exponents equal to each other.
Oh, yes, you're right.
So 2 can equal to x over 8.2 to keep solving for x. But we can only do that once we have made the bases the same.
Okay. And then you do it all the
Just cross multiplication. Any other questions about this one? Solving for the exponent here rather than for f of x? Yes? No? Sort of? Let's look at another example. Number 3 says in 30 hours a sample of plutonium decays to 1 over 256 of its original amount. We want to know what the half-life was. Again, this is not dealing with the initial. We don't really care about what we initially started with, we just know what we had left. So we can let, given the fraction is the same as saying it as a percentage. So we can say that what's left after 30 hours is 1 over 256 of k. The k ultimately cancels out. So we don't need to know what we initially started with, we just need to know what's left of it. So from here, again, we need a common base. So we need to change our 1 over 256 to a lower base, which in this case was a half. It's always going for half-life questions, your common base is always going to be a half. So you got to figure out what half to exponent will give us 1 over 256, which is 8. Again, we can set our two exponents equal to each other. So 8 is equal to 30 over h. Solving for h, you're going to get 30 divided by 8, which is approximately 3.75 hours. Okay? I've lost you anywhere, please let me know. Lucas.
How did you get 3.75?
You gotta cross multiply and divide, right? So 8 equals 30 over h. We cross multiply the h. So we get 8h is equal to 30. And then we divide the 8. So it's 30 divided by 8, which is 3.75.
Well, the k's always cancel out.
The k should always cancel out. If k isn't given to you, then how it's worded, the k should always cancel out. So it's either given to you as a percentage of the initial, or in this case, it's given to you as a fraction of the initial, but it's ultimately the same thing. The only way k doesn't cancel out is if they actually give you the initial and they give you the final amount. So if they tell you you had 250 kilograms of something, and then you want to know how long it takes to get to 100 kilograms. Well, in that case, you know f of x is 100, you know k was 250, you plug it into the formula and then divide. Any other questions about half-life? So far, so good? Nothing too complicated, I hope. The other case is going the opposite, which is the doubling period. So when something doubles in size, so it's getting bigger, exponential growth. How do you think your formula will change with the doubling period?
The half will just be a 2.
The half will just be a 2. Yeah. Can I move on from here? So when it's a doubling period situation, when something is doubling in size, the formula is pretty much identical, except that in this case now the growth rate is 2 instead of a half. And then we just change the half-life notation from h to d to represent the doubling period. But ultimately the formula is the same. F of x represents the final amount, k represents your initial amount, x is the time period in the question, and d represents your doubling period. And just like with the half-life, x and d must be the same unit. So if they're not the same unit, you need to convert. And I always recommend convert x to match the d or x to match the h. I would always recommend that. That's an easier conversion than the opposite. Between the two of them, it should be very obvious which is a half-life question and which is a doubling period question. Why should that be obvious?
2.5.
No, it's from the question, Julia.
Oh.
How from the question should you know right away if you're dealing with half-life or you're dealing with doubling period? Aldrich.
We're going to be talking about material, and half-life, and
Yeah. It will specifically, in a half-life question, the term half-life should appear in the question in some fashion. Either the question will say this substance has a half-life of this, or it'll say somewhere like find the half-life of this substance. Like half-life should appear in the question. And when it comes to doubling period, doubling should appear in the question. It will say this substance doubles in size every 2 days or whatever. That expression should be in the question. So you shouldn't have difficulty telling the difference between the two. Let's do a question. Here we have one bacterium divides into 2 bacteria every 5 days, doubling period. So initially there are 15 bacteria. How many bacteria will be there in 30 days? I let x represent the elapsed time in days. F of x is going to represent the number of bacteria present. I initially start with 15. So that's K. X is the 30 days we're calculating, and D is the 5 days that the doubling period is. They are both days, so we don't need to do any converting. We just need to plug it in. So f of x is going to be 15 times 2 to the power of 30 over 5. Well, 30 over 5 is 6. So what we're calculating is 15 times 2 to the power of 6. Please remember proper bed mass. The biggest mistake I see people make is multiply the 15 and the 2 together and then go 30 to the power of 6. That's not right. Remember, bed mass tells you do the exponent first, then multiply. So you should be calculating 2 to the power of 6, which is 64, and then multiplying by 15. Or you should just use your calculator properly. Because if you just type it in your calculator, it should be a no-brainer. Questions about that? Not so challenging, I think, yes? Questions? Is there, again, just look over the solution, make sure if I lost you along the way, let me know. Next. Let's look at 5. So we have a culture of bacteria, starts at 3,000 bacteria and grows to a population of 12,000 bacteria after 3 hours. We want to find the doubling period. X represents the elapsed time. F of x is going to represent the number of bacteria present. We started with 3,000, so that's K. We ended with 12,000 after 3 hours, so f at 3 is equal to 12,000. X was 3 hours. What we're looking for is the D. We're looking for the doubling period. So we can plug everything in. 12,000 is equal to 3,000 times 2 to the power of 3 divided by D. Dividing the 3,000 gives us 4. Equal to 2 to the power of 3 over D. Again, we need to get a common base. So we can change the 4 to 2 squared. So the base is 2. Which means we can now set the 2 exponents equal to each other. So 2 is equal to 3 times D. Which means, solving for D, we get D is 3 over 2. So our doubling period in this case is every 1.5 hours. Any questions about that? And usually these formulas are very straightforward. You're given one unknown and you just solve for it. Part B asks for an expression to now represent the population after T hours. So, because our doubling period worked out to a fraction, we just need to kind of solve this. So we're just plugging in. Our original equation was 3,000 times 2 to the power of x over d. The d we found to be 3 over 2. So we know our, hopefully, division of fraction rules. Yes? When we divide fractions, we do what? Multiply the reciprocal. Is that what people were mumbling? Hopefully, you multiply the reciprocal. So x divided by 3 over 2 becomes 2 times x over 3. Do I need to show that?
Yeah.
Yes. X divided by 3 over 2. Right? When we divide fractions, we multiply the reciprocal. So that's x is going to be times 2 over 3. which means x times 2 over 3. Fractions. We love them, we hate them. We have to deal with them. They never disappear, ever. Again, if you're hoping that one day fractions will stop being relevant, fortunately that's not the case if you keep going in math. Christian, you okay? Oh, okay. Looks like you're getting a headache. So far so good? So last question. Determine the number of bacteria present after 8 hours. How do we do that? We just sub in 8 for x. And calculate. So you get approximately, or more like on the nose, 120,952. Again, please make sure, most of the time people get these wrong just from using your calculator incorrectly. So please make sure you know the proper ways to input this information to get the right answer. You have to, the calculator is a wonderful thing as long as you use it properly. Okay? People tend to think that calculators are to think for you, but no. Your calculator is only as good as your entering skills are. So if you're not entering the information in properly, it won't work out. So particularly what I mean by that is, this exponent, you should be using brackets to calculate this. So what you should be typing in is 3,000 times 2. Okay, so type in 3,000 times 2. When you hit your power button, open a bracket and go 8 times 2 divided by 3, close your bracket, and then hit the equal sign to get this. You didn't get this? It should have a decimal to it, but okay? So it should look like this. So 3,000 times 2. I know the 2 has a bracket, but you're not going to put a bracket around the 2. What you're going to put a bracket around for your calculator is the exponent part. So you should be typing in 3,000, then your exponent key, times 2, your exponent key, whatever it may be, then you open a bracket, 2 times the 8 divided by the 3 and close your bracket. That's how you should be entering in your calculator. Try it out to make sure you're using. I find people don't use your brackets properly in a calculator. You should not, ladies and gentlemen, you should not be using your brackets in your calculator to represent multiplication. Some calculators allow you to do that, but you really shouldn't. The brackets in a calculator are really meant to say, do this calculation first. It's not really supposed to be meant to show multiplication. So like this bracket with the 2, you should not be bracketing 2 in your equation in your calculator. You have a multiplication button if you need. Any questions about half-life doubling period? Half-life doubling period. If you're reading your question carefully, you shouldn't get the 2 confused. And you shouldn't get them confused with the word problems we did on Friday. Because the wording of those problems are very different. How are the wording from the questions we did on Friday? Questions we did on Friday should always have a percent change. Something is increasing by a percentage or decreasing by a percentage. Versus half-life will have half-life in it, doubling period will have doubling period in it. These types of word problems should be, like you should be able to put them out very easily because the wordings are very different. Okay? Questions? Okay. Start doing some work.